Okay, this is the example for of the work on identities. You've got an expression that you need to show as true. So we've got the secant of x times the cotangent of x on the left hand side, and we need to show that that is equal to the cosecant of x on the right hand side. So the way you go about doing these kinds of problems is you split up your work into left hand side and right hand side, and essentially what you want to do is you want to show that you have an expression for the left hand side which is exactly equal to an expression for the right hand side. So looking at this problem, my first instinct is to work on the left hand side because it's got two trig functions, and on the right hand side we've only got one. So we need to work out and see whether or not we can simplify that product on the left hand side so that it equals one kind of function, and hopefully that's going to be cosec of x. So let's just write down what the left hand side is, and then we'll look to see whether or not we can simplify that using some of the formulas that we've just been given. So the left hand side is equal to sec x and multiplied by cot x. Okay, now what we're going to do is we're going to see whether or not we can break down those functions into its simplest building blocks, and the simplest building blocks are sine, cosine, tangent, etc. In particular sine and cosine. In fact, the simplest block, the block on which everything is based, is the sine function, but sometimes you're going to have some sines, some cosines and tangents in there as well. So let's just see if we can break this down. So sec x, we know that sec x is 1 over cos, so we'll write that down. So instead of writing sec x, we're going to write cos. So we're going to write 1 over cos for that expression. We know that cotangent, or cot x, is 1 over tan, so we'll just write that down for the time being, 1 over tan. What we're now going to do is we're now going to rewrite the tangent part of that expression. We're going to leave the first bit as 1 over cos x. The second part, we know that tangent of x is equal to, let's write that on the right hand side here, tan x is equal to sine x over cos x. So it's one of those identities that we've just been introduced to. So we're going to use that identity to break down or to rewrite the tan function. So I'm going to write, so if tan x is sine x over cos x, then that means that 1 over tan x is equal to cos x over sine x. You just flip those, that fraction on the right hand side. So cos x over sine x. So I'm going to write that expression in my left hand side expression here. So I've got cos x over tan x, over sine x, sorry. Okay, and now I can see I can actually simplify this. So I've got a cos x in my numerator and I've got a cos x in my denominator. I can cancel those two bits out, and what I'm left with is 1 over sine x. And then I'm looking to see, well, what am I working my way towards? I'll go back to my original expression. The right hand side is 1 over cos x, and what I have is 1 over sine x, which is in fact, so the right hand side is cosec x, which is in fact 1 over sine x. So I can now rewrite this 1 over sine x as cosec x, which is my right hand side. And every time you do these kinds of problems, your final statement should always be the left hand side is equal to the right hand side, which is what I've done there. Okay, voila, I've proven that sec x times cot x is equal to cosec x.